Continuing on with our Unit 2, talking about assemblies and putting things together. We've been making things in Fusion, like all these pieces that are here. So now we're going to start talking about how we can assemble them in Fusion so we can kind of get an idea of how well things fit together or don't fit together. So the first thing you'll need to do is go to your resources folder. So in Hoban Engineering, open resources IED, and we're on 2.1.3, and there are two files you're going to need in here. But we're going to start with this joints demo to begin with. But while we're here, go ahead and copy. So right click and go to copy on these, and then you're going to need to go to Hoban Engineering, and then go to your class period and make a copy of this to your folder. So make a copy of the joints demo and the selfie stick. Right click, copy, make that copy. Once you do, we're going to start with this joints demo first, just to talk about the ways we can attach different objects in Fusion. So the first we're going to talk about is a rigid joint. So in order to start assembling objects, we have this tab up here called Assemble, and there's some different ways we can assemble things, but the simplest we're going to deal with is called a joint. So we can click here where it says joint, or it has the shortcut, the letter J. So I'm just going to hit the letter J, and it'll bring up this window on the right, this joint window. I'm going to cancel that for a second. I can also go to assembly, go down, hit joint, and I get the same window. So in this window, right now I'm selecting my origin mode is simple, which just means I'm going to pick the point on here that I'm attaching to. There are two others, between faces and two edge intersection. We'll talk about how we would use those later. Right now I'm selecting the snap point for my first component. So I want to attach this rigid block to the rigid base. And these snap points that we're using, if I rotate down to see the bottom of this rigid block, the snap points, if you see this cursor with the blue, red, and green lines coming off of it, that's my snap point. I'm picking a spot on this block that I'm referencing. So I'm saying this point on this block, that's the snap point I've selected, is going to snap to, I'm now selecting component 2, its snap point, it's going to snap to this spot. So I pick the middle of the bottom of the block, and I'm going to pick the middle of this opening, and that block slides into place. Mine automatically started spinning. Yours might not do that, but if I go to motion, so on this we have position, which we set, and then in motion we get to pick the type of joint. Mine at first was set to revolute, but I'm going to switch that now to rigid, and it kind of shakes, showing that they are now locked together. So if yours wasn't already rigid, make it rigid. We have now made a rigid joint. So if I hit OK, now if I try to move these pieces, they no longer separate. They've become one kind of like assembly of pieces. Next, we'll look at revolute. So I can hit that letter J to pull up my joints menu. I'm going to do something similar. I'm going to go to the bottom. I'm going to select the center of that piece. Come up here, my second component, the center of this. And now my motion type, I'm going to set to revolute. And then when I set to revolute, I get some additional information. So I can change the axis I'm rotating around. So right now it's rotating around the Z axis, which looks appropriate. So if I go to preview motion, I can see what that motion looks like. But if I change this to Y axis, for example, we see it gets a little bit wonky right now. So Z axis is the axis we want it to spin around. So we'll set that so it spins around the way we would expect it to do. So that's a revolute joint. So now if I grab this, I can spin that object around in Fusion and see how it interacts together. Next, we have a ball and socket. So we're going to hit the letter J. And now when I'm selecting my joint, I get to pick my snap point. With a ball, it's a bit more difficult. So I'm going to show you kind of the issue. When we go across this sphere, we have snap points, little white points that pop up along the surface. So if I just go down to the bottom and pick that point, and then in the socket I do something similar, I go find a point at the bottom and put those together, it'll go into that position, and right now it's spinning to show that revolute joint. But if I go to motion and change this to ball revolution, you see it's rotating around that single point we gave it. So we don't actually want it to rotate around that point at the bottom. So we're going to go back and change the position here. So we go to position and we deselect those two snap points. And what we want to select is the center of this ball. So this square, this white piece in the center, that's the thing I'm looking for. So now I'm snapping the center of this ball similarly into the center of the socket. And now when it goes in, it spins around as we would expect. And if you notice, it kind of ran into the pieces of the socket in different positions. There's a way we can limit that. So if we go to motion, we can set minimum and maximum limits. So I can kind of move around and see where the ball can fit. So in this direction, I can say has unlimited, so I don't need a minimum or maximum in the pitch. If I go to yaw, now I can set the limits for the yaw of the ball, like the angles it can turn, or similarly, I could set limits for pitch. So I can go through and decide how far it should be able to move in any of these directions. That's not something we need to deal with at the moment. I'll show you a different way we can make that happen. So if right now we're just going to select these two, and as long as we get a ball joint for this ball and socket, it's okay. And we'll fix or I'll walk through how you can fix the issue where it like goes through an object later on. Right now, that's how you do a ball and socket unit. We've picked the center of the ball and the center of the socket and snapped them together. Now let's go to a slot and base, or a slot and pin. So this pin can kind of go into this slot and kind of slide around. So same thing, we'll hit J. And now what we care about, or what we're concerned about, is the faces they're going to be meeting. So right now, if I pick a snap point at the bottom of this pin, and then I go to this base, if I pick the center of this arc, it's going to attach the pin up here, and we're still at a ball and socket joint. So let's go switch that over to, we'll do a pin and slot. You see now it's kind of moving back and forth, but the pin is very high. So when you're making your selections for your snap points, I'm going to deselect my second snap point. You need to make sure you're selecting a snap point that's in the same plane. So I picked the bottom of the snap point for the pin. So I want that to be lined up with the bottom of this slot base. This snap point I'm trying to get to is floating in midair. So sometimes it can be difficult to get to those. If you're having trouble, go to the surface you want it to be matched up with, and then hold Control. And then if I move over, it'll make sure it goes to that snap point I want. So now it's locked into that position. Something else that might happen is what it's doing right now for me, which is it's upside down. So I have this button that flips it over to get it in the correct orientation. Now we're going to go to motion. We're still at a pin and slot. We're spinning in the Z-axis and we're sliding along the X-axis. But I want to slide along this edge. So I'm going to my position, and I need to change this X-axis. So for my slide, instead of X-axis, I'm going to set it to custom. And then I'm going to select the axis that it's going to slide along, which is this axis. So now it moves back and forth the way I would expect it to do. Similarly, if I go to my slide in my joint motion limits, I can set some limits where I can drag where the product or the object will be limited to go. So I can say its minimum is going to be 0. And then for me, the maximum, if I set it to 2.3, that means it can go all the way to this position. So I set a minimum and a maximum, 2.3 inches, and hit OK. And now I have a pin and slot, and it'll only move within those dimensions I have provided. Next, we're going to do cylindrical. So a cylindrical joint will allow this cylinder to spin inside this one, and it'll also move up and down along the cylinder. So hit the letter J for a joint. I'm going to grab the bottom of the cylinder for a snap point, and then similarly I'm going to get the bottom of this opening so that they align together. I'm going to change my motion to cylinder or cylindrical. Now you can see it's moving up and down in the cylinder, and it's also spinning freely. And I don't need to put any limits in this case. So we can spin freely and move up and down within that cylinder. Second to last joint, we have the slider base. So I have this little T shape that's going to fit inside this slot, and then it can slide back and forth in that dimension. So hit the J for joint. The position you choose will determine how it will align. So I'm going to pick, if I go on this face, I can pick the bottom of this face, and then I would pick the bottom of this. So that's what I'll do in this case. So when I go to this edge, you can see if I move around, this is the same point, but that marker kind of turns. So this is going along the axis versus this is on the face. So again, make sure you're on the face. So I'm going to go to the face, hold control, and now go to the snap point. And I'm going to do the same thing over here to get to this snap point. We're going to change our motion type to slider. And then our position, we're going to flip so that it goes into the way that we would expect. So we have the slider cap fitting in the slider base. Go to motion, and I'm going to set a minimum and a maximum. And then my maximum, I'm going to set, actually we see if we go all the way over, it's -4 inches. So this is 4 inches in length, but because of where I put mine, the negative has to be the minimum. So now it has a motion limit that it keeps it onside this slider base and locked into that position. And then finally, we have planar. Planar joints will just make two surfaces be aligned with each other. So with the letter J for joint, I'm going to pick a planar joint. And my first snap point, I just need to pick something on this surface. So it doesn't matter what point I choose. I'll just do this square that's like the center of the triangle. And then I'll pick the center of this base. And now I've created a planar joint. Now if I go to move this, I can see it will slide. It'll slide along the face, but it won't go up into the air. So if we go to a front view, this triangle or this pyramid won't go up at all, but it will slide and stay on this plane. Similarly, if we go up to the top view, you can see a bit better. It'll slide everywhere in this plane, but they are just locked in that relationship. So these are different types of joints we can use in Fusion to build some assemblies, and we can see how they fit together. This is really useful when we're trying to build something that is multiple parts that are moving around each other, because it allows us to kind of like see where things would interfere or not, similar to this ball and socket. What you guys need to do next is we're going to build this selfie stick. To do that, you have this document, which has the kind of like a drawing diagram of that object. It's like how these pieces are coming together. One thing to note is not all the pieces are present. We're going to be using a component that already exists. And that's kind of getting to the part of we're building these assemblies. So I'm going to show you how we're going to pull that screw into this assembly. So looking at Fusion, we have this insert button. We're going to insert MakeMaster Car component. This pulls up a window where we can insert different screws and components from a place called MakeMaster Car, which is where you can order a lot of hardware and other machining parts. So the part number we're looking for is part number 9118 5A 911, and we get this thumb screw. So I'm going to click that. Once I do, it pulls up that thumb screw in this tiny window. Let's see if I can enlarge it a bit so you guys can see. So I have this part, and then down here we have the CAD file of that part. So I can add it to my order. So this is where you can like pull parts in to see how they work in your finished project, and then you could immediately order them, and then you would know they would fit. But I'm going to go to this CAD file. So right now it's set to 3D SolidWorks. Instead, I'm just going to go to 3D Step. So I'm going to click 3D Step and then download. Then after your computer has some time to think, it will drop the part into your CAD file, and you can just put it over to the side and we'll use it later. So just hit OK. And now that part has been added to our assembly so far. So there's some parts and pieces that are here. We're going to be using some different joints to assemble these things together. Right now we can grab and move them around, but we need to start doing some joinery. So the first thing we're going to do, we're going to join the inside piece of this rod. So I'm going to select the inner bottom side of this rod, and I'm going to look all the way into the outer piece. So make sure you get the bottom circle here and get in the center, and it'll bring that other piece over. We're going to change our motion type to cylindrical, so it can spin and it can move in and out of this cylinder. We're going to set limits to the slide. We don't need any limits to the spin. So limits to our slide, the minimum is 0 because that's where it's at. And we're going to set a maximum. As we slide this out, we can see about 11.5 inches. And we're going to hit OK. So now that inner piece will move, but it stops when it gets to 11.5, and then it doesn't go all the way back through the object. So we're good there. The next piece that needs to go on is this piece. So J for join. I'm grabbing this part, the bottom circle. I'm going to attach it to this. You've noticed we have these threads on here, so it's hard to get the center of the circle. We can't use this circle either because it's off center. So instead, I'm going to go to this surface. I'm going to hold Control, and I'm going to go to the middle. So if those pieces come together, I'm going to flip my joint. And then instead of cylindrical, this will be a rigid joint. It's going to be locked to that piece. Continuing along, we have this piece that's going to be in. So J for joint. Now, instead of using a simple joint, we need to have this be centered inside of this. So I'm going to do between two faces. I pick the two faces I'm between, which is I want to select a point that's between these two that should be the exact center. So I pick those two faces, plane 1, plane 2. Now the snap is going to be the center of the circle. And then if you see the red, blue, and green lines show up in the middle, the snap point is right in the middle of this object. Now I'm going to do the same thing over here. So between two faces, I'm going to pick these two faces that it's going to be locked between, and then I'm going to pick the center of that circle. And now that piece comes in. This will be a revolute joint, and we'll have some minimums and maximums of 90 degrees and or a maximum of 90 degrees and a minimum of negative 90 degrees, and hit OK. So we have that piece on there. Next, we can put this thumb screw into that position. So to do that, J for join. And I'm going to grab this inner surface. We have to do that same trick where I hold Control and I go to the center of it. And it goes in this position, in the center of that circle. And we can have this be revolute. In reality, this would be more of a cylinder, like you'd have to screw this in and out, but we're going to make this be rigid for now. Just because as far as our model is concerned, we just need to make sure those things fit together and that they could exist. So nearly done. Next, we have this component, which will have this screwed on. So we're going to attach those two things together first. So J for joint. Hold Control, go to the center of the circle, come to this side, hold Control, go to the center of the circle, and those pieces come together with a rigid joint. I hit OK. And now I'm going to join these two pieces together on these two pieces. So going here, hold Control, go to the center of the rectangular piece, and we'll do the same thing over here. So I go to this, hold Control, and you notice I can't really get to the middle. So since I want this plane to match up on here, if I were to pick this position, for example, you see it kind of like digs into the object, so I don't want that to happen. So instead, I'm going to use that between two faces. I'm going to select between these two, and then my snap point, I want it to be on this surface up here. So just that gives me the piece in like a weird orientation. Let's see if we can flip this from here. No, I'm struggling with this. All right, new thing we're going to go into then. Let's keep it a simple joint, and we'll go to the center of this where we have that step off, but now we're going to offset this away from the base. Looks like 0.12 maybe, 0.125, yes. So we're going to offset at 0.125 and lock that in for our rigid joint. One final piece, hit joint, grab the center of this circle, go here, hold Control, go to the center, and do the same thing over here, Control, go to the center, and make another rigid joint in that position. So at this point, you should have something that looks like this. Yours might be spun around a bit, but this should still be here. So you should have something that can freely rotate, and these arms will kind of move in and out. And then additionally, these can move in and out to like hold your phone in place. So this is a selfie stick that you've assembled. So at this point, save this file and save your joints demo file. Those two files being saved and complete as all you're submitting for this project or for this assignment.